Welcome to TUC lecture series. Today we are going to discuss a few very important DFA design, the binary numbers which is divisible by some integer. So let the first example, binary number divisible by 3. So first of all, we have already taken a table of 8 values 0 to 7 and their corresponding integer. Now think about the numbers which is divisible by 0. Now when we divide a number by 3, so absolutely here we get 3 remainders, 0, 1 and 2. Whatever the number is, we always obtain 3 remainders. So I have designed a table here. Column is remainders and the values under each heading columns are the numbers which is divisible by 3 between 0 to 8. So number divisible by 0 are 0, 3 and 6. 0, 3, 6, which give the remainder 0. So number 1, 4 and 7 would give remainder 1, and 2 and 5 will give remainder 2. Okay, so for 3 remainder in the DFA design, we have to take 3 states for 3 remainders. Q0 actually signifies the remainder 0, Q1 remainder 1 and Q2 for remainder 2. So we always start with self-reference 0, because if you take number of zeros, which is divisible by 3. Okay, so next comes the state for remainder 1. So if you take 1, number of 0, 2, 0 and take the 1, then we reach to state Q, that is remainder 1, that is the first value here, 0, 0, 1. Now the next value for divisible by 3 is 0, 1, 1. So from Q1 we reach again to Q0, so that we get the string value like 0, 1, 1. Now one thing is important to note here, that we are taking string value 0, 1, 1, that is we always consider is decimal equivalent 3 when we talk about divisible by number. So whatever the binary string we are forming here, we always consider the decimal equivalent for that, so that we can easily get the remainder and put which value goes to which remainder section. So next value, if I take Q1 and then a transition 0 to Q2, so the value here is formed like 0, 1, 0, so reach to Q2, that is remainder 2. Now this value is checked, this value is checked. Now for this value 1, 1, 0, so if we start with Q0 and take 1, then again Q0 takes 0, so this value also verifies. Now the 1, 0, 0 for Q state 1, take 1 then 0. Now Q2, from Q2 we have another transition 0, so 1, 0, 0, so this value is also recognized. Now the value for 3, 3, 3, 3A ones. For this we start with Q0, take the transition with 1, then go back to Q0, then again come back 1, so 3 ones. This is also recognized. 1, 0, 1, 1, 0, then from Q to a self transition, so we also this object. So this is not only true for these values only. We can take any string uh, take a string like 1 0 1 1. So this is 0 1 2 3 4. So this is 16 plus 8 plus 2 plus 1. This is 24 26 27. So this is 27. Is it divisible by 3? This will get the remainder 0. So check the string. So start with 1. So you Q0, then again 1 to goes to Q1, then again taking 1 it go back to Q0. So there is a 0, the self transition point Q0, then again take transition with 1 to Q1, then Q1 go back to Q0. So we reach to the accepting state, that is a divisible by 3. So this string is recognized by this DFA. So in this way we can verify any binary string with this transition diagram. So this is a transition diagram for any binary number divisible by 3. The same logic we can apply for other divisor like 4. So for 4 you are getting 4 remainder here, 0 1 2 and 3. Now check which numbers will fall under which heading of these remainders. Like for 0, 0 is divisible by any number, so 0 comes under remainder 0. So 0 divisible by 4, then 4 divisible by 4. So for remainder 1 this is 1 and 5, remainder 2 will be 6 and 2, and remainder 3 will be 3 and 7 for the divisibility of 7. Now again similarly we start with a 0 transition to itself Q0. So Q0 is remainder 0, Q1 remainder 1, Q3 remainder 3 and Q2 remainder 2. So there is a transition with 1 to Q1. So 0 1 recognized by this value. So 1 0 0 for 1 0. So from Q1 we transition 0 goes to Q2, then again a transition from 0. So 1 0 0 again goes back to Q0. So 0 and 4 is recognized by this transition. Now for remainder 1 we have 0 0 1. So 0 1 circular 0, then 1 this path 0 0 1. So this is remainder 1 Q1, we reach to Q1, then 1 0 1 1, the 1 Q1 to from 1 for 1 we start with Q0 and reach to Q1, then take 0 and reach to Q2, then again we have 1 to reach Q1. So this is how we reach to remainder 1, this is Q1 state. For Q2 0 1 0 1. For Q2 we have 1 1 0. So we start with 1 and again 1 and then again taking a 0, so we reach to Q2 1 0 0. So it is also recognized. 0 1 1. So taking 0 1, taking 0 1, then again 0, so it goes to Q2. So again this is recognized. For remainder 3 we take 0 0, then reach to 1, then Q2. Okay, so this part. So this is recognized. For 3 1, So start with Q1, then reach to Q1. Sorry, start with Q0, reach to Q1. So 1 is recognized, then stay again taking a 1, reach to Q3, and in a Q3 we have saved loop with 1. So 3 ones is recognized by state Q3. So remainder 3 is also is constructed like this way. So this is a DFA which recognize any binary number divisible by 4. So as we did in previous DFA, take another string and then check the DFA, we can also verify this DFA with such a given string like 1 1 0 1 0 0. So this is 0 1 2 3 4 16 plus 4, that is 20, which is divisible by 4. So let's see what happens. We start with Q0, take a transition with 1 to goes to Q1, then we take 0 to goes to Q2, then again we have obtained the input, consume the input 1 and goes back to Q1, then again we have obtained 0, reach to Q2, then again a 0, reach to Q1 Q0. So in this way you can verify that any number divisible by 4, or either divisible by 4 or would give some remainder between 0 to 3. So this is a DFA which recognize any string divisible by 4. Similarly, we can also obtain a DFA which is divisible by 5. So in the case of 5, we have remainders like 0 0 1 2 3 and 4. So 0 divisible by 5 and 5 divisible by 5. For remainder 1 1 and 6, remainder 2 2 and 7, remainder 3 is 3, remainder 4 is 4. So these are the odd numbers, possible numbers, which comes under the different classes of remainders. So again we have a self loop with 0 goes to Q0. From Q0 to Q1 as it goes to remainder 1. So 0 0 1 goes to Q1. 1 0 1. So for this string we have to go Q1 to Q1 to Q2 with 0 1 0, and then again a string transition from 1 back to Q0. So 1 0 1 is recognized and is accepted by Q0 state. So remainder 1 we already have shown that 0 0 1 is possible to reach Q1. For 1 1 0, that is this value, for this value we have to take another transition like 1, then again we goes to Q3, then taking a 0 this goes back to Q1. So 1 1 and 0 you can multiply by Q1. So these two values completed. Then for remainder 2, so start with 0 Q0, taking 0, then 1 goes to Q1, then takes a 0, go back to Q0, this way Q0. So 0 1 0. So this is completed. Now triple 1. So first one this, then goes back to this direction, and then Q3 to Q0. So second number, that is 1 1 1, is also recognized with Q2 state. So remainder 3, the value is 0 1 1. So from start with Q0 it's taking 0, then Q0 to Q1 with 1, and take a transition with one q1 to q3, reach to q3 0 1 1, and for remainder 4 start with 1, reach to q1, and taking a transition 0 from q1 will reach to state q4, and taking any self transition we also fill the remaining zeros, so reach to q4. So this is why we fill the remainder, and similarly we can also, taking any arbitrary string, verify that which is divisible by 0 or provide any remainder from 1 to 4. Thank you very much.